I have a few slides to kick us off.
Sounds good.
I will steal this back.
So it's following others now. To upload. This is on YouTube now. We are live streaming now. Billions of viewers flooding in. It will be amazing. And then we just
Which one was my card? This one?
Har jeg slået den på hende? Det?
Are you seeing
Nå ja, det gør kameraet. Det er sådan en ansigtsfølger. Eller har den statisk? Ja, det er Henrik Kjøb.
Yeah, but no, I can hear it. It was just a delay.
Ah, okay. Er den statisk, eller følger den? Er den statisk, eller følger den?
Lige nu er den
Okay.
statisk, og så laver vi den lille. Så den statiske nu tager det der.
Okay, det var, skal vel fange hendes ansigt.
Det kommer til lige om lidt.
Yes. Okay. All right, everyone. Can I have your attention, please?
User acceptance test passed.
So please take a seat, and we will commence shortly. Thank you very, very much for coming to Pydata Copenhagen. It's great to see you all here after a brief hiatus. And so many people had chosen to not go to Italy and spend their summer here with us. So that's great. So who here is here for the first time at Pydata Copenhagen? Okay, very nice. We like to have like 50-50, so it's good to see some new faces. And just for fun, who's been here before? Yeah. Okay, so for those of you who are new, Pydata is a part of something called NumFocus, which is a fiscal sponsor of all your favorite projects, including Pandas, Jupyter, Scikit-learn, lots of R language packages, and other open science tooling. And Pydata is kind of their conference suite, including the meetups from all across the world. That also means that we follow the NumFocus Pydata Code of Conduct. So there is a longer version. I will give you the shorter version here. So we are kind to others. We do not insult or put down others. We are professionals and behave professionally. We do not tolerate any harassment, any sexist, racist, or otherwise exclusionary language at Pydata. If you are in any way uncomfortable in a conversation, then please do come find myself, and we will try to resolve the situation to the best of our abilities. We have not had to enforce any of this in the 6 years we've been doing this, so let's not make today the first time. So, practicals. The bathroom is down there on the first floor.
Exactly.
Yes.
Yeah, so unfortunately, the bathroom on this floor is out of order, but if you just go one floor down, first door on your left, we put up a sign. That one works. It's all good.
Okay. Bathroom sorted. One more. We put up a bag over there for the cans. So please, if you find any empty cans or if you are done, please put them into the bag over there, and these nice people can get their pence back. And finally, the Pac-Man rule, a very important rule here at Pydata. So we're here to meet, network, and hang out. So it's pretty important that we're able to join other people's conversations. And it can be hard to do that if we're all cramped around in a circle like this, which is a very natural thing for us to do. So follow the Pac-Man rule. Always leave a hole in your group of people. When someone joins you, then try to open up again so that someone else can join your conversation. And that is the Pac-Man rule. The corollary is that try to keep it in English. We have a lot of people from lots of different nationalities. And I'll definitely try to switch as soon as possible when someone new does join the group. So for today, we have the Alexander Institute as our sponsor. So I would like to ask Dan to come up here.
Fancy microphone. Hiya. So just very briefly, we're very happy to kind of sponsor this Pydata event. So Alexander Institute is a small-ish consultancy of around 100 people in Aarhus and in Copenhagen. We do tech consulting, basically. So it's like both AI, but also cybersecurity and various other things, computer vision and so on. What's a bit different, like distinguishes us from other consultancies, if you will, is that half of our time is research. So we do conduct our own research half of our time, and we do consulting work for companies for the other half of our time. So we kind of, it's a weird split in between like industry and academia, if you will, where our goal, so we get some money from the government to kind of convert the knowledge that we have from academia into things that can help us, things that can aid us to help companies. So we're kind of the transitional layer, if you will. And yeah, that's all for me. Thank you for coming.
Thank you very much, Alexander Institute. So we also have our usual community announcement section. So this is for anyone in the community who has a job opening, some other event going on, something else. Yeah, we have a hand.
Consultancy, okay?
Yeah.
Okay. It's a bit specific, but if anyone here is super good at HiKISS, meaning automating and doing processes in the specific queue keys. And if that sounds absolutely confusing, that's because it is. Then I would probably be very interested to talk to you. We don't have a super budget yet, but that's very much under discussion. And what we're looking for is not just doing, but also teaching for a small team in my organization, because we use it quite a lot and interested in moving it forward. Thank you very much.
Yeah, thank you. Anyone else want to share? No? Then, without further ado, one more. We do need you, because we can only run these events if we have speakers who are willing to take the time to come up with something to present on the stage, and that needs to be you guys. So if you have something that you're passionate about, something you care about, we can always turn that into a talk. Just come find me or write me on LinkedIn or Slack or any of the other channels. I'm happy to help you get your idea into a talk. So yeah, come find me if you have any ideas for that. And that means we are going to the main event of the day. So please welcome Charles to the stage. And you brought some guests today, but I'll let you introduce them. So you just have to do the ritual dance of technology. Oh. Hey, there we go.
Okay. Thank you, Anders. Thank you, Dan and the Alexandria Institute for hosting. My name is Charles, and I've been a musician for twice as long as I've been a data scientist, which means that I don't have any professional experience in video games. So I've asked a couple of friends to help out today. And the first of whom is a Super Metroid player and speedrunner. Anatomica, also known as Dave Hunt, technical artist at Unity. Unity Technologies is a game engine that I am ashamed to admit that more than 50% of games are made on it, and even though I'm a hardcore gamer, I hadn't heard of it until I met people who work there, but now I have, and it's very cool. So Dave is a technical artist at Unity Technologies, and he's also a speedrunner. Dave, come and help me out. What is Super Metroid?
Super Metroid is a game released on Super Nintendo back in 1994, so almost 30 years ago today. I love the game. I've been playing it since I was a kid, and every few years I'll go and play it again. And recently I started checking into this whole speedrunning community and wondering what that's all about. And
what is speedrunning?
So it's sort of like you see here. People will put a timer next to their recording of the game and trying to go as fast as they can. And they can upload this video along with the data from the splits editor to speedrun.com. And it's highly competitive, and like world records are being broken even today. Like just a week ago, the new world record was improved. So it's a really active community. It's pretty cool. And I've been kind of a casual player up until just a couple months ago, where I started dipping my toes into this world of speedrunning. So.
And you were interested in, where did this all start? You posed a question.
So, like, one of the first questions I think I said was, like, I think that this game, of course, is my favorite game. I have sort of tunnel vision to it, and I was like, I think it's like the most speedrun game of all. so, what did you say?
Oh, okay. Well, most speedrun game. What does that mean? So, I get to my next pause. Next slide, please. Please. Yay. Okay. So I got onto speedrun.com, where people log their speedruns, which is how fast they can play a game. And when you have a look at this, you do see a story of Super Metroid really representing in the Super Nintendo Entertainment System speedrunning community. So here is Super Metroid, and they have 82 active players. Now, active, that sounds like very few, but to be active, you have to have uploaded a speedrun in the last 30 days. So that's a pretty harsh cutoff. Total players that have played Super Metroid are almost 2,000. It's a small but devoted community. But in particular, they have the most runs logged, the most speed runs logged. So even though they're smaller than some of the other communities, they do bump up. So when I first collected these data, they were at the top of the active players list, but they're currently, as of last night, in third place, but very close to the same group. And so I thought, okay, yeah, Super Metroid's representing pretty high. Like, if you look at active players, runs, and total players, Super Metroid is in the top 5 for all of them. But this is the Super Nintendo Entertainment System. So what about active players across all platforms? So that's where we found some really interesting things. For example, so like what is going on here? Like we've got, okay, so the first thing that jumped out at me was what's going on with Subway Surfers? Like they've got way more total players than all time and way more runs. Like all other games would have just been decades to catch up to what Subway Surfers has pulled off in quite a short amount of time, because it's only from 2012, whereas Super Metroid's from 1994. So it had a moment, so I got on the internet and it's like, why would this be a thing? So what the internet and various threads and various Reddit forums and whatnot told me was that in Brazil, they mostly play mobile games. They don't play consoles. They can't afford them. The economy just, it's not viable for people to play console games. So they play mobile games all the time. Subway Surfers, very big mobile game. Then there was a TikTok speedrunning phenomenon in Brazil, and it took off on TikTok to post TikTok videos of your speedruns. So it got really popular. And if you go onto TikTok and type #speedrun, #Subway Surfers, all in Portuguese. So I discovered this. Subway Surfers was a Brazilian TikTok phenomenon, and it's not anymore, because if you look, it's down to 283 active players, which, given, you know, the 50,000 that have played it in a few years. Same thing was just happened, we noticed, with Minecraft Legacy. Must have had a moment, because people logged a lot of, well, there's been a lot of players, feel like it's the second most number of players of all time, but only 8 active players at the moment. So I've never done a speed run. I've never really heard of it. It's like, I love, like, this is my favorite part of data. It's like exploring things. I feel like Dora the Explorer, discovering things I didn't know about. So Super Metroid is not the most speedrunned game of all time, but it is the most speedrunned Super Nintendo Entertainment System game. And I think when you look at Super Metroid's runs compared to and I've included the top 5 of every category in this bar plot, Super Metroid really represents a number of runs. Look, so it's got a small but very devoted community of guys who mostly are guys from the videos I've seen, all guys so far, and middle-aged, because this is a 1994 game. So it's this sweet community of, you know, dads playing this old 90s game. And that is the data we're looking at. And so once we got talking about Destiny, and he said, yeah, well, people put it on leaderboards. And I was like, if there's leaderboards, then we can get data. So how do we first? It was quite to get to these data was a whole journey. There was learning XML packages first. I think the first thing we were looking at was in XML. The next thing I was pulling down was
Scraping website.
There was, we tried curl API and using the REST API curl commands, but for some reason it only capped at 25 and I couldn't figure out how to iterate through. But then I found a Python module that implemented the REST API. Like, okay, Python, this is feeling a lot more comfortable. And from Python, I was able to get to nested dictionaries. And I am this project old when I learned about list comprehension. It was great. There's a whole website, which I'll drop into the meetup link, where I've got all the code and experimentation. And it's been fun to put this together. So, but once I finally have my data, what can I do with it? Now, Dave wants to know, when do they get competitive? To answer this question with our data, I built a dashboard, and so I'm going to ask my second friend from Unity, Cecily, who is Danish, and I'm using the Australian pronunciation so that I don't mess it up, to help out as my professional dashboard operator of the evening and token open science stakeholder. So we've got 2 people who work in video game technology helping me out today. And now, Cecily, this plot is a bit hard for Dave to see anything, right? You can't really answer your question about what times do they get competitive? And in particular, Dave's interested in, you know, the rankings of players. Like, what about the top 100? Or what about the players around his rank? So here I've got our dashboard. Could you limit the ranking? Let's get rid of the bottom 10. So take it to lowest rank is 590. So at the moment there are 600 speedruns logged on speedrun.com. For Super Metroid 100% runs, which is where they collect all loot and defeat all bosses. There's many different categories, but broadly speaking, speedruns are split into any percent and... Is it updating? Is it not updating? Tell me it's not. It's not updating! Tell me it's not broken.
Probably me who's doing something wrong, you know?
It's not updating. That's a bit scary. Let's try 200. It's like it's gone dead, isn't it? Oh yeah, yes. Use a non-broken keyboard. It's not reacting at all. But it's also like it's gone dead. Yeah, like the app's gone dead. Hang on, I'm just going to hold this.
You have extended empathy.
Yeah.
We empathize.
Yes.
Yeah.
This is the first time this happened ever, yeah.
I tested it right before.
We know.
Yeah.
But it is possible that the Shiny server just timed out.
Yeah.
So let's hope it was that.
But maybe, so this is our studio, and then you're running a Shiny server? Oh, okay.
Yes, this is a Quarto notebook, and then I'm running a Shiny server within the Quarto notebook.
Okay. Cool. Thanks.
So what kind of notebook?
Quarto.
Okay.
.qmd, so I've got Python and Bash chunks in this. It enables me to use whatever code I like. I'm very happy to show you demos under the hood once I'm done with the presentation. Yes, you could absolutely. Is it working? Yes, it's working!
Great dashboard.
This, and see, professional, this is why you bring in the professional dashboard operator. So now you can see a little bit more about our speed runs. We can see, what do you see?
I mean, so
You're the speedrunner.
I'm looking at these numbers and thinking, so how good does my time have to get in order to be competitive? And at first I can finish the game in almost 3 hours, and I'm thinking that's better because it normally take maybe 7 to 10 hours for a normal playthrough. Yeah, 3 is pretty good, right? Well, where does it really get competitive is my question.
Well, what do you think? So here we've got what it's called a rain cloud plot. So each dot represents a speedrunner and their speedrun time in the x-axis. We've got a standard box plot in the middle and a density plot. I love these, combining the three things. So we can see that most of the speed runs are bunching up here. I feel like we're not going to get competitive until we look at, say, like the top, 200 players. What do you think? When we're interested in kind of ranking. So, Cecily, professional dashboard operator.
I wanted the lowest to be 200.
200. And so now what do we learn? We can see, so here we've got the dashboard operating on rank because that's how Dave thinks about running, but he wants the answer in time. So the visualization is answering, well, what are the times that the speedrunners get? So we've got here the first 200, so they're all falling within this range of like 70 minutes, or 112 is the current world record.
112.
From 112.
1 hour and 12, that is, so not 112 minutes.
1 hour 12, yes. So 72 so from 72 to 90 minutes is where you can see it gets quite competitive. Like when we get into this kind of zone, this is where like the top 200 players are bunching, and that is not a lot of time, I don't think. And it seems like there's different hurdles that they go through, but we're going to look into why that is in the next visualization. And let's have a look at your. Oh, sorry, did you have a question?
Just one. They are humans. These are humans.
These are humans. Each dot is a human.
Yeah. Okay.
Yeah. So each dot is a speedrunner.
That you sort of.
I mean, I could answer that too. Yeah, these are all people playing the game manually. There's a different kind of speed running called tool-assisted speed run. It's called TAS, and that's where someone uses a computer program to script the inputs precisely per millisecond, and then that way they can explore what's possible. But those don't count in the world leaderboards. You have to be a real person pressing the buttons. So, yeah.
Oh, we've got more. Yes, yes, please interact, ask questions.
For some reason, I know a little bit about this. So it's so for TS runs. Two questions: is Metroid deterministic? And two, what's the actual record on TS run?
Good question. So I'll repeat them for the microphone. Is Super Metroid deterministic? And I'll answer that next. And secondly, what is the world record for a task run or a tool-assisted speed run? So I think the task runs get under 1 hour. The world record is, and I have to check the actual 50-something minutes, I'd guess. And yes, it is deterministic. So you will get precise results each time. However, there's plenty of what we call RNG. You know, there are random numbers generated to determine like what pattern of attack the boss enemy has, and people do learn to manipulate that and get expected results. But let's hear it. What's your next question? Yeah.
In terms of RNG, how big a factor do you think that is in the human speed?
Oh, it's huge. Like I just watched the personal best achieve for the any percent category by Oats and Goats, this YouTuber, and he was complaining the whole time because he wasn't getting power bomb drops. You critically need to get this one piece of ammunition in order to make it through the next. So he had to take a deviation of like 1 or 2 seconds to go and pick up farming, an enemy, and that comes close to ruining his run. Yeah. Then they know the predictability of it. There's a 60% chance of getting a drop from this one enemy type, and they get all upset when it doesn't drop.
There was another question?
Yeah. Do you also have another visualization where you show these submitted runs if they're from the same players or the...
Yeah, so that is one of the engineering things that that ended up going not for this talk. At the moment, the runs are not being categorized by runners, but this in the speedrun.com it doesn't have historical, so this is just the best run for each runner. But in the splits data set there is historical data because I didn't want to throw away the runs. Yeah. But in this case, yes, each one is one runner because it's their best time. I did actually want to try to get the historical, but I haven't figured out how to get the historical data out of the API. I'll open an issue. Yeah. So I think we've got, let's go to the next slide. I can't remember. You might need to sort of, there. All right, so he said, well, now that we've got, this is great. He's like, but the speedrunners, they're recording these things called splits, like these game events of when exactly they get a particular piece of loot or defeat a boss or something like that. And speedrunners are always trying to finesse, like how fast they can get from here to here, like a particular 3-minute section of the game. So they talk about their very specific splits, which are durations. And for us, that's going to be less of a useful sort of idea in data science term. I would say game event because it's a single time point, and we think about durations and time points. So game events, they want to know the specific times, and from the speedrun leaderboard, we don't have that. We've only got the end time. He said, well, there's this website where you can upload your splits times from the this is the open source emulator that plugs into the open source plugin for an open source emulator for the video game, and the plugin records the time points. Everything's open science. It's just stuff people have made in their spare time. I had a really nice chat with the guy who maintains the Splits.io Python implementation about what we could and could not get out of the data. It's quite surprising. So, do you want to riff a little on splits?
You can press play on that video. So this is what it looks like as a speedrunner to set up your splits. Use this program called LiveSplit, and I'm now going into the editor and deciding I want to add a new split at the beginning to track a game event. So you go to settings, and it has a giant list of all these game events. It's like beating a boss, picking up a power up, and so I'm going to choose Ceres Ridley. He's the first appearance of the Ridley boss in the beginning of the game. So you check the box, and now I have to go in and manually add this entry and name it whatever I want. And people name them funny things because they're being funny. And I can choose an icon for it and get a nice little picture of the boss monster that I'm fighting. And so there, I've loaded it up. Now I have a new split. It shows up at the top, Ceres Ridley. And when I go and play my game, notice the timer starts as soon as I press start right here. So the timer starts. We're going on the first new segment here. And as I run through the station, we don't have to watch the whole thing, but as soon as I get to that event, it records the time, and I can see.
Let's wait to see the recording.
Sure. Okay. You can see my really sloppy Ceres station run here. I'm losing all kinds of time by bonking the doors and stuff.
It's very late to be able to finish the game in 3 hours. It's very hard.
Yeah. Question back here.
But like from your emulation, that's also like so it shows you some like developers would say debugging information up top.
Yeah.
So that's so the community has agreed this version of the game where you can see like the inputs and outputs is the.
Yeah, the precis. This is the actual game that you want to use when you're speed running. There's also a practice hack where they've gone and added all these extra features for jumping straight to a specific part of the game for practicing. And if you want to just suddenly refill all your energy and ammunition, you can run a command like that. But yeah, there's using this version of the ROM guarantees you're not cheating because there's no special stuff going on. Okay, so it just recorded my split. Since it's the first time I did it, it can't compare against the last time, but it'll have a plus or minus if I'm going faster than my last record.
So I thought, great. When I saw that he could do this and he showed me a file and I got so excited, I downloaded his files. I was able to build like a little time series of his various runs and compare them. And then Dave says, oh, well, there's a website where people upload these files so that I can get them. But as it turns out, those tick boxes, the machine readable part, and I went to the package maintainer. He said, no, he doesn't think he can get it. There was currently no way that I found to extract the machine ID for that tick box that's selected, which means in order to identify the game event, you have to go with the text description that the player puts in. So now you have this massive text mining problem. Because, I mean, this begs the question, what route is best? And so this is the data set that I pulled down from splits.io. And I'm not gonna rock the boat by trying to click the hyperlink to show you the leaderboard right now. It might break my slides. Let's go to the next slide. Yeah, thank you. So I thought, oh, okay, well, if I plot the segments over time, the order that, then I should see, everyone accumulating time, because each run, at each game event, they're getting further and further. But if I plot it over time, it is not monotonic, people. It's not always increasing. And this is not the way I was expecting it to look, but I kind of love this about visualization. Like, bad visualizations are also kind of good, because in this case, the bad visualization is telling me that the data are not monotonically increasing, which means that people don't go to the same game events at the same times or in the same order. So now we have a question about routes. And I think our next slide shows that yes. And I'm going to ask Anatomica to riff a little bit on the map.
Sure. So this isn't like too big in terms of games of today, but back when this came out in '94, this game is enormous. There's so much to explore, and the way the game works is you can't get to everything at first. You need to get power-ups that allow you to traverse the environment farther, and defeating bosses opens doors to exploring further. And the game is designed to be played in one particular sequence. But if you're clever, you can find ways to short-circuit that sequence and skip parts of the game. And that's what speedrunning is all about. And people get really clever about going, oh, all I need to do is go to these few places. I can beat the game in like 40 minutes. Like the any percent record is right around 40%. Any percent meaning I don't have to get everything. I personally enjoy playing the 100% item completion. So that's where you actually do have to go and get everything the whole game. So yeah, is that good?
So it begs the question, doesn't it? What routes do players take through the game and which route is fastest? But in order to do that, you have to be able to identify which route a run took. And that has been an interesting question to explore. Let's look at the next slide. Okay, so I was like, okay, well, what if I take, all the splits, I have different game events, and I say, well, I know that they're sequential, so, we can engineer this so that the data set is ordered according to the splits, and I can set it up into in this case, I use a tidygraph from to data frame, where I've got what node is going from, what node it goes to, run it through my thing. So, and this is the default graph that you get out, and like, okay, well, there's a lot going on here. So it's connecting every time each node is a game event, and each line is one player who has recorded a connection between those two adjacent events. So that one's just a mess. Let's have a look at the next tab, see whether, you'll need the mouse for this one, to go to the order tab. Yeah. So then I thought, well, let's try and impose some order on it. But this is a little bit disorganized, but we do get a bit more information about. You can see that there are certain events that are being recorded a lot and certain events not so much. So there's real inconsistency, but it's like consistent inconsistency, as Matthias and I were talking about the other day. There's a missingness, but there's a missingness kind of pretty evenly distributed across the routes. So, well, we need direction. So we need to have some kind of sense of what goes after one another. So let's have a look at a linear graph where we're clustering the game events that are near each other, but we don't have the direction, like which game event they're going from and to. We need a directed graph, not just a graph. So the busy one, this is a directed graph. Now, I like this. The mechanics of this I learned for this project. It is so cool. So very hard to see, but the arrows are the arcs are proportional. The height of the arc is proportional to the distance between the nodes. And the arrows on the upper level are going forwards. So these arrows are all going this way, and underneath the arrows go backwards. So that seems like a useful setup, but it's still too busy. So then I went to Anatomica and I said, well, okay, talk to me about what you're really interested in with the routes. Like, you're my person that I'm consulting for this. Whatever, he's my gamer that I'm talking to. So which strategies are you really interested in? And so we distilled it down to some strats, because now we've got something, and now I'm going to ask Anatomica talk a little bit about the different route strategies for speedrunners and the ones you can see in this picture.
Okay, so in order to beat the game, you need to beat 4 bosses first, and that opens up the door to the mother brain, the final boss. For the 100% category, there's 2 main established routes, and it's considered the early Crocomire route and the late Crocomire route. And that's a question of like, how soon in the game are you going to get the grappling beam? The fastest players can be expert and skip it and get it late, and it's about 20 seconds faster. So conventional knowledge in the community is that if you're good at this game, you do the late Crocomire route.
Okay, so there's the grapple beam
right here. So people are doing it in different orders according to this visualization. But I had a question about this, like, well, are there top runners who are using the early Crocomire route? And is it really necessary to do that extra hard route? Because it's kind of more fun to play it the other way. I'm a casual. You know, my best score is just under 2 hours now, and then I'm nowhere near competitive. So, but yeah, the data speaks for itself. Let's see what the results are.
Yeah, so we've got some information about what the players are doing, but we don't have it finessed based on rank. We've got a sense of, okay, a lot of people are going from the grapple beam, and then some people are recording, and this is the misleading part about it, is players choose what they record. So there's lots of missingness in this data. So these players may have gone from, so some people have gone from grapple beam to Fantoon and then to space jump. But some people have gone straight from grapple beam to space jump, but that might just be because they didn't record the intermediary thing. So it doesn't tell us about the rankings. And then there was much exploring of, yes?
Could also not be missing this, because it's a Metroidvania, essentially some paths are blocked you until you get certain things. So like some of the missing can be explained with them just not being able to do it.
Yeah, that's absolutely right. We have someone knowledgeable about the Metroidvania genre. So, I mean, like,
watched a lot of speedruns.
That's awesome. Truly, like, this game and Castlevania Symphony of the Night spawned a whole genre that's really popular called Metroidvania. And you're right. You know, they block you off, and you can't get there until you do a certain thing, unless people get really clever about wall jumping, or maybe manipulating the hitbox so they can go right through a wall. And then, some of these strats are not allowed. They're considered glitches. Like going out of bounds is not allowed in my category. But there is the glitch category. You can finish this game in like 17 minutes. It's crazy. Once again, I'm not that good. So.
And this is why we are sticking to 100% runs, because you can see how if I took into account those and tried to build that into subgroup analysis, no, because then we have incomplete routes. No, that's just even harder. So let's explore the routes based on rank now. Yeah. So we did try various different approaches. We tried some machine learning, we tried some hierarchical clustering, and tried a few different things, but the missingness of the data really poses quite a big challenge because people don't necessarily record, say, this is set to Ice Beam, the Ice Beam game event when they get the Ice Beam. So if they don't record that, anyway, what I got to thinking was you can answer a lot of these questions that he has with some exploratory data analysis. So here I've got, on the y-axis, we've got every run, and then we've got every point, every game event that runner recorded. So each line going across is a run. And then I've got them ordered from the best to the worst runs, which is where it kind of looks like this kind of, I think it looks like a waterfall. So I had a rain cloud plot, now I have a waterfall plot. So I like how it just worked out that way, very water themed. But here we've got it set to Ice Beam. It's a little bit hard to inspect the data, so I think I'm going to ask my professional dashboard operator to pull in our x-axis a bit, I think. Like, we want to pull it down and inspect the data, so let's like restrict the maximum time down to, say, 150 minutes. Because most of the runs are finished in that. And so now we can inspect it much more closely. And in this way, this is where you start to see the clusters. So you can really see, this is the Ice Beam event. And one of the strats that the speedrunners talk about is early and late Ice Beam. And you can see it in the data. There's the early Ice Beam, there's late Ice Beam. But what's nice about ordering it in terms of the best runs is you can see the very best runners are favoring an early Ice Beam route. But if we compare this to another gamer event, Grapple Beam, thank you, dashboard operator, we have different clustering. This is also a different strategy that's talked about on the gaming forums. So Anatomica has educated me about this. So you can see the very best runners are now favoring late Grapple, but almost everyone else, and people are having a crack at the late Grapple, but most people, so late Grapple must be really hard, I assume. Whereas let's have another look at, so most of the other splits, everyone's pretty agreement. So dashboard operator, let's pick a different one, just pick whatever you like. I picked out the two most interesting, so now we will look at the uninteresting ones.
That was very uninteresting.
Yeah, so everybody does this one early. Oh yeah, and here's Anatomica. I mean, this one I've managed to, I intend to put Anatomica in all the plots for the when I put the dashboard online, but here's the pale blue dot. So.
Does anybody you want to see on the graph?
Mothball. It's a classic. Yeah.
Ah, you know! You've got knowledge!
Can't do much without that one.
So everybody does early Mothball.
But then the sort of the y-axis of the pale blue dot, is that an expression that you don't play that much, or what is?
Oh, the pale blue dot is a reference to Carl Sagan. So Anatomica loves Carl Sagan's The Pale Blue Dot, and so it's just a reference to how he loves that. I think it's a book by Carl Sagan called The Pale Blue Dot. Bombs is boring.
It's just consistent is what that is.
And what's nice about that, when you go through and you inspect each one, you see that there are really only a few splits that have these clusters. So then now Matthias and I have been like meeting for coffees and just enjoying this project together for funsies. Matthias is up the back there. Thank you, Matthias. He's been my machine learning advisor on the project.
Check out Ridley. There's an interesting...
Oh, Ridley. Okay. Yeah.
Okay. So Ridley, like I said, is the boss. That's one of the final ones that you usually fight. And when we did this, we said, wait a sec, how are some people doing it first? And then we realized this is probably, I think you had the explanation for this, right?
Yeah, well, I think, so you said that, oh, well, the string that people would use to describe some other early event also, right, so, but this is, I think, a really nice illustration of how data visualization and exploratory data analysis really goes to data quality. Like, it just pops out at you that these have been mislabeled. And yeah, I love that kind of thing. So this gave us a way of inspecting it without the complexity of the various different machine learning things we tried, a way of answering the question, what do the best runners do, what do the less good runners do, based on different splits. And I really love how much information we were able to get out of something kind of really so simple. So on to our next slide. That leads us, so here we go. So this is the, yes. So this is the data set that I cleaned up for me and Matthias to play with. So in case you want to, the data is there. It's part of the package associated with this talk. And if you want to play around with this missing data, this is what it looks like. So here we've got each row is a run. And then I've labeled a class of route if they've recorded the exact same things in the exact same order, because that did diminish, did bring me down from, 500 different routes to 150 routes. But even then, and there's a whole page on this on the website, the combinatorics of when you get to all the different combinations of routes, I realized the string matching wasn't going to work. But the thing is, they are sequential events. So you have a real-time value for when that event happened for that player. So even though it's missing, and even the thing is, if you had, say, a single ice beam value, because ice beam has late and early, that run, even if it doesn't match with many other segments, we should still be able to classify it by early and late ice beam under various different classification algorithms. And so the next slide, please. Thank you, Cecily. So this is what Matthias and I were talking about last week, and then I had to pause and actually make sure the dashboards worked. And I'm sure you all know how much work the user interface of dashboards takes, and just cleaning up the data to get it into these visualizations. So this, I decided to just present it as an open problem rather than solve everything myself. We got sort of halfway through experimenting with doing a KNN imputation for the missing values, because we don't want to do column-wise, because you're going to lose the very clusters that we just saw with the ice beams and the grapple beam. We want to capture that, so we need to get the adjacent values under the projection of the subset that is, missing for each route. So these were the various things we poked around with, and there's various stages of code and experimentation on the site. But I've also packaged up the data if you want to play with it yourselves. And I think we're on to, so that was my open problem. Please come and talk to me about any of this afterwards. And next slide, I think yes, now we're coming up to the end, and my motivation for this talk is I am unemployed. I would like to find a job in Copenhagen as a data scientist. I don't think I have enough exploratory data analysis in my portfolio, and I think I do have some skills. So the motivation was to find something fun to produce a lot of exploratory data analysis. I'm going to stick it on a shiny dashboard online so that I can just add it to my CV. So if you want to help out with any open science to help improve my dashboards or my visualizations to help me improve my portfolio and do some open science, please get in touch. Post about this on LinkedIn. I'm giving this talk to also just connect with the open science community. I haven't been here that long. I came from Australia. I do want to make friends as well. And so on the next slide, I have a very, very quick just little rundown. I'm looking for mid-level, and I just want to find a team of people to do fun data science with. That's the short of it. I like doing data science. I come from a math background. Then I went and did a PhD in statistics. Boring. Anyway, find me on LinkedIn, talk to me afterwards. Moving on to the final slide. This is my favorite part. We put together a blooper reel of all of the visualizations. Yeah, hit play. And now we open up for questions. Thank you so much for listening to our presentation. Thank you so much to my co-presenters. Please, everyone, give my co-presenters a wonderful round of applause. Yeah.
This is going to be very nerdy. Is there a path for 100% run?
Yes, indeed. I think I probably watched it, and it's incredible to watch the precision of a task run, and it does go 100% and capture all that.
Like, if the task is a theoretical best run you can get 100%, then wouldn't it be also interesting to kind of look how people deviate from the theoretical best? Right.
That's a great question. So I'll repeat it for the microphone. Wouldn't it be interesting to compare what the tool-assisted speed run can do compared to human, using this sort of data analysis, I think, right? Absolutely. So if we could get the splits data of one of these task runs, we could have a lot of fun with it. And certainly the speed runners will use that as a way of trying to refine their strats and seeing what actually is the fastest. And yeah, there'll be makes for some good data science, I think.
Yeah.
So there is a research topic on extreme events of breaking records. So this is a very popular research topic, and it's very used especially in sports, because like when you
of course
stuff like that. And one of the main questions is what is the probability that there will be a new record, given that there was a record a week ago, or a day ago, or a month ago. And there is quite of a very strong law on that. It's related with power laws and stuff like that. So I think this type of data that you have here, it's actually an interesting set of data to do this type of analysis, because there is a lot of data compared to 100 meters and stuff like that, on which world records are not so common.
I like that. Wait, repeat that again to me, and I'll repeat it to the audience. So it was, because that's a great idea for an analysis. So it's when it's predicting when the next record will be broken on it?
Yeah, that's
right.
The main...
One of so something that's often done in sports is to try to predict when the next record, and saying that this would be a good data set to do. That sounds like fun. Oh, this one's great. Oh, the memories. Any other questions?
So the number 10 best run in your category, that record was from 2017. Is that correct?
Is that what you saw in the?
I think that's
right. So the number 10 best one was 2017. Yeah, they're and some of these records stay a long time, many years before someone can top it. Yeah, but they're still getting topped regularly. I think
20th of June.
2 weeks ago, 20th of June, Shiny Zenny got new personal best by 3 seconds. So he now.
So
yeah, it's a really amazing run. You can watch it on YouTube and Twitch. Question right here.
Yes, Henrik.
How much effort did you put into creating this presentation and all this background? And but I think the interesting part of this, how much did it take you to research and understand the problem? And what did you spend to do data ranking? And then present this in a way so it was meaningful to an audience like us?
Wait, no, that's not. That is the spear.
You just see the result, and it's hidden from everyone else how much is put into.
That's a good question.
The number 42, right?
Yeah. So the question is, how much effort did I put into it? Well, I built an analysis site. I'll link you to this right afterwards. This is a packaged down website that's got all of the code. Not all of it compiled, but for example, you can check out all my various experimentations. So how much effort? Well, I went down a rabbit hole. It started as a weekend thing. Like, I'm job hunting, and it's really miserable job hunting and boring, and I'm bored and I miss doing science. So on the weekends I started doing this for fun after these conversations about the data sets, and I got kind of sucked in. Then I thought, well, I should actually use this for portfolio. And then I thought, what better way to meet data scientists in Copenhagen than give a talk at Pydata? So I actually put a bit of effort into this. So here, for example, in the, identifying roots of root matching. Yeah, the root matching. So here, when I sat down to do it, it turns into abstract algebra if you write it out. I've even got the algebra embedded in the website. But when you get down to it, and when I tried to do some string matching to see whether I could do some join engineering to get the roots down to a lower dimensionality, I thought even if I could just get it down to say 30 roots or something, that's something I could work with. But And I did try. So this is what here is like, this is what I was looking at, you know, it's trying to make sense of the problem. It's like, okay, so go in different routes. So I've never played the game, so I'm trying to understand it. But this is always the way we go in data science. We never know the domain. We only know how to use the computer to try to understand and answer the domain questions. So here is a specific route of all the splits that some player has recorded. Then these are all of the runs that have collected them. And then I don't know why there's duplicates. Why they weren't there before? There's always things going wrong with the scripts. But you can start to see the missingness, especially when you scroll down and you see they get smaller and smaller. And then I started to realize, yeah, I'm never gonna, like when you calculate how many, where's the number? Anyway, somewhere in here is the combinatorics of like there's 40,000 combinations. This wasn't going to work, but it was kind of fun to just engineer it for a moment. So how much? Well, I had fun. I learned list comprehension. I learned a lot about dashboards, and I'm very bored because I'm unemployed. Yes, Keith.
So you mentioned that part of the task was to be able to distinguish like the root names from the names that you have assigned.
Yes, I could talk about that.
Particularly what you have used, because that is one of the challenges that I'm dealing with currently. And I found ChatGPT very convenient and useful here because it can replace several kind of regular expressions if you kind of properly prompt it in terms of like identifying what kind of root from your diction or like the source of truth that can refer to. So
that's just really interesting. Can you send me the prompt that you used to do that?
Yeah, I'm using it in medical terms, but
yeah. No, but I'm just interested in like because that sounds useful. But now I want to see the prompt that generated that.
One challenge that we had was like to clean data that was like typed as a free text. And doctors are typing medical terms, and there are like typos, there are like dosage of the medicines, there are like how the medicine has been used, and so on. And that needs to be mapped into a standardized medical term. And we have tried using regex to take out the dosage, and it's several lines of regular.
And then the thing is, the regexes end up like conflicting with each other, and you end up introducing new engineering problems because you fixed those 14 entries, but now you've introduced a new unexpected one that takes 14 months to find.
ChatGPT can recognize these and can go even further because I cannot identify if a word is an actual medicine or an ingredient, part of that medicine, but ChatGPT can.
Yeah.
So not only can replace a lot of regular expressions, but also has some knowledge about the meaning of that word. So I think that could also be useful here to try to label these.
Oh, the labeling is not, because in the end we experimented. I tried using a package called Fuzzy Join, but it misclassified some stuff, and so I was still needing to hand it over to my domain knowledge expert, the speedrunner, to actually classify, because he knows that Ridley E-Tank is not the same as Ridley, whereas I'm not going to know that. So in the end, after experimenting with Fuzzy Join and trying to, and then Matthias and I had several conversations about, well, can we use machine learning to do this labeling? And in the end, I'm like, right, that's it. I'm just taking every unique one, I'm putting it into a Google Sheet, and I put in drop-down boxes and just handed it off to Anatomica and asked him to do the relabeling for this. Yes. So that is an open problem on it, is how do we do that kind of labeling with the machine in a way that's not going to overly pollute? Now, in a situation like this, I don't mind polluting the data set a bit, because we're just going to inspect the visualization at the end and say, what do the fastest people do? What do the slowest people do? So it's kind of these broad strokes, and I don't mind, but even so, the Fuzzy Join didn't give me enough. So yes, I'd be very interested in your thoughts, anyone's thoughts on that, because I agree, it comes up all the time. Then the text labeling. I mean, well, you're sitting next to Dan, who talked about natural language processing at Pydata recently, and yes, text, it's always a bitch. Any other questions? You're welcome to come and chat to me afterwards. I'm more than happy to go, pop the hood and show you the code. Yeah?
It's a bit of a same vein of the whole task thing, maybe you could analyze the influence of task runs on human runs. Meaning, if you have a certain history, I presume you also have a date or a time code for a task run, and if that becomes number one, does it actually change strategies from human players? The way you've actually seen that in chess, especially, that something has happened as soon as people understand that something was, that the computer has discovered something new.
I love it. I love all these ideas for analyses. Yes, keep generating them and sending me ideas, people. Yeah, do you want to?
Yeah, I think you're right on there, because what people do is discover stuff when they're working with tasks, and then they prove it works in a run, and then the whole community learns about it, and then everyone improves their scores. So you can truly see where these events happen. Like there's an event called Moonfall, when they discovered if you're moonwalking and shooting and jump backwards, you fall and you exceed terminal velocity. Everyone's like, you can save 3 seconds on that fall. That's a lot. And so everyone goes back, and you can see in the records truly the point where Moonfall became known several years ago. And
I guess it also means that someone has done some sort of gaming AI with task runs as well, because that's not a natural thing to discover. Because that's a tactical AI half glitch.
Yeah,
that will boom, we do that.
Exactly. I think that once we see AI figuring out how to run a task, then we'll see discoveries that we haven't even found yet. And I'm not sure how much that's being done yet, but that certainly is there's a lot of potential in there. Yeah, and see what it does when it figures itself out by brute force, running this, a million times in a simulation. Yeah. Another question here.
Isn't a lot of it that like a player experiences something weird like once by accident, and then they use the task to go and figure out what happened?
Exactly. Yeah, you can slow down the video and watch, and then replicate what happened in a task. So once again, there's a recent example. Shiny Zenny was doing Zeeb's Escape. It was the fastest way to get off the planet when it's blowing up. And he discovered this trick when you are bonking into a door with Speed Booster with Shine Spark. Instead of just falling to the ground and running in, you do a down back. So that means you push yourself in horizontally while you're falling, saving a few frames. And you do that across the whole run, and it adds up. And he has the world record now on the Zeeb's Escape because that he learned from his experimentation with tasks. And he says it, yeah. So you guys are on the ball. This is cool. I want to see what happens when the data scientists get involved with this. So
you're well within the 3 a.m. YouTube rabbit hole of my brain.
Yeah.
I wasn't familiar it was Trackmania, but it's similar discussions, and it's data science, and it's awesome. It's lovely.
Yeah. To me, it's one of the best applications of data science. I'm joking because this is really just for fun, but yeah, good stuff. Another question.
Yeah, Dan first.
So I was just a bit interested in the routes. So I haven't played this game, so I'm not sure are there any constraints on the
Let's get the map back up.
If you go do this split or this task, then you have to go to a certain other one, or does it is there structure to this graph?
Sorry, Sweet.
There definitely is some structure to the graph, especially when you don't allow glitching. Glitching is going out of bounds, and then all bets are off, and you can do it in whatever order. But if you're playing with no glitches 100%, then yeah, there actually are true limits. And that's why you see a lot of consistency in those route graphs. The one looks like a big waterfall. Even the top players are doing it pretty consistently with guys like me, down at the bottom. So, all right. Totally. Questions all over the place. I think I saw your hand first, Beck. Another one here.
Yeah.
Okay, go ahead. Yeah.
So my question is whether the hardware plays a role in the timing.
Sure.
Good control.
Oh, yeah. So does the hardware play a role in your timing? Absolutely. The top players play on console with a CRT TV because that is the lowest latency. And the first-party controller is the best. The one made by Nintendo. Newbies like me are playing on PC emulator, and I found the best third-party controller I can find, and it's pretty good. But I got one, and it was garbage. I couldn't wall jump. She saw me, she's like, "Who is this noob?" And it's like, I'm throwing away this controller. This is embarrassing. And hardware really does matter. And like when I was playing it first on the Switch, the Joy-Cons are garbage. You can't get them. And then I said, great, let's buy a controller for this. But there was a little bit of lag, and you can't have any microseconds of lags happening here. So certainly the hardware makes a big difference. Yep. Another question in the back here. Yeah.
I'm terribly sorry if my memory fails me, but I think your data was represented in a tidy data frame.
Yes.
Okay. So what machine learning? Two questions. What machine learning approach were you planning on doing? I think it was KNN.
Yeah. Let's talk about the.
Have you thought about using a graph machine learning approach?
No, come and talk to me afterwards. Yeah, but would you like to riff on that a little bit now?
Because like you were showing routes and passages and everything else like that, and so I just Googled because I'm using graph databases at work.
Right.
And so I just kind of wondered, and I looked up graph transformers.
Yes, I don't know anything about graph modeling techniques. I mean, yeah, I taught graph theory at one point, but that was just pure math, right?
Way more than I do, okay.
No, but that was just graph, like it's just, the proofs. Like we proved the 5-color theorem. It was really fun, but it's like relating that to like how I do machine learning, not just still connecting the dots, yeah. It was a real revelation when I was sitting down trying to write out the root joining thing of like, how can I match up these strings? And then when I wrote it out in my notebook, I just kept borrowing math symbols as I went and going, well, yeah, but this is really like a class and this is a subclass and, really, and I need something that's like, something that says subclass, but that's kind of like subset. And I'm like, well, I know how to use, I know these symbols from math. So, and then when I got to the end, I'd written 4 pages of abstract algebra, and it was just algebra. So, I mean, engineering, data engineering, and I've got my notebook here, you can come see. It's straight up abstract algebra. Yeah. So that part I feel like on this project I really connected my pure math background into, but graphs, I would love to learn more about how to, yeah, because there's so many mathematical results in graphs. We must be able to use these in modeling context, and I just don't know about it. Yeah, great idea.
Is there a last question?
Yeah, I don't know if you told it earlier in the presentation. How did you hook up?
How did we meet?
This project, yeah.
Oh, yeah, we're friends. So we just got talking about, I was like, he's always on about Super Metroid.
Having coffee and chatting about this, I'm just mentioning these odd details and like assuming that I actually know the conclusions of the data. And she's a data scientist, so she couldn't help but, and she found out that the data exists. I produced this XML file, and she popped up like a meerkat, and she's like, "There's data? Give me the data." and it was awesome. And then, wait, there's a whole website where people all upload their data like this? Okay. And so that's where we get the large amount of data, and that one looks like a waterfall there. And right, it was exactly.
Yeah. It started with these .lss files from the emulator. He said, I've got these files here for previous runs. So I grabbed the files and I plotted the mean and the standard deviation of the duration of every split that he'd recorded across different runs, so that he could get a sense of which runs he was having the most variance on and which ones were taking the longest. And then I didn't get time to, this was the very start, and I didn't get time to like pretty it up, get the code running to put it in. But I did a little hierarchical clustering to identify 3 clusters that gave him like, these are the runs that go really quick and you don't vary much. These are the runs you vary a bit, but they're quite short. But then there was a 3rd cluster where the average length of the split was 13 minutes. So these are the long ones, and they have high variance. And there was maybe 6 or 7 of those in that cluster. And so that was a really nice use of clustering to go, this is what you should focus on, just these 6 bits in the game. And as a piano teacher of 20 years, so this is part of what drove it. Was I taught piano for 20 years, and I'm like, are you practicing from the end of the game? Because the mistake piano players make is starting from the beginning of the piece each time. You get very good at the start, and you never learn to play the end. So I was asking, I bet it's probably your latest splits, and then I'm kind of like, let's show the data.
She was right about it. So like, we could tell the consistency of my runs by looking at the data, and the beginning is totally consistent because I practice it way too much. like she said. In the end, it gets more varied. So she's coaching me with like basically professional trainer, piano teacher skills. It's true. So, yeah.
Data science esports coach.
On that note, let's thank you. So thank you very much to all the lovely assistants and to Charles. We are, of course, sticking around, and I'm sure Charles will be happy to answer any more of your questions. It looks like we have a nice hybrid of speedrunning community and Pydata, so who knows? Yeah, we have plenty of drinks.